will be there if I will use it with /24. But I need how many IP address between router 1 and router 2? Only 2 IP address. That's why I'm using /30 to reduce the wastage of IP address. Yes or no?
Yes.
Let me hit enter over here. Are you able to see Gracious ARP here?
Yes.
Right? Tell me what will be the source IP address inside this Gracious ARP?
B.2.
Source 12.1.1.1.
What will be the destination?
.2.
Oh my God.
Oh, the the FFF, the broadcast.
No, destination IP. I'm not asking about the destination MAC, by the way. Destination will be same now in Gracious ARP. Same, right? What this machine is trying to do? This machine is going to check that this IP address is duplicate or not. So source will be also this one, destination will be also this one. If there is a device who is using this IP address, that machine will generate reply. And if this machine will generate receive any reply, it will give you error that this IP address is duplicate. Yes or no?
Yeah, then it would be broadcast for that.
Not broadcast. If it will be broadcast, then this machine will also generate reply. Yes or no? Because broadcast means it can be for me also.
In Gracious ARP doing like that, no? If the source
In Gracious ARP, source IP will be the sender IP address. Destination IP address also will be the sender IP address. Source MAC will be the MAC address of sender, and destination MAC will be the broadcast.
Yeah, destination will be broadcast.
Right? If you want to verify, you can verify. You should verify these things by yourself in GNS3 or in any simulation software. If you will open it in detail in the here, Gracious ARP. See, what is the source? Sender IP address is 12.1. What is the target IP address? Same.
Same, yeah.
This is the source MAC address. MAC address of router 1. This is broadcast. Destination is broadcast. Yes or no?
Okay.
Right?
Sorry, man.
Now I am going to configure IP address on router 2. Router 2 will also generate Gracious ARP. Yes or no? Source IP will be 12.1. Destination will be also 12.1. Sorry, 12.2. Source, destination, both will be 12.2. Yes?
Yes.
Interface F0/0, say no set, and the IP address. IP address is 12.1.1.2, 255.255.255.0, 252. Yes? See?
Yes.
Both machine have generated Gracious ARP, but anyone have not received any reply message. Yes or no?
Yes.
That means both IP address is unique. So both have assigned the IP address. Now my next question is, one, I have assigned IP address on both machine. Yes or no? Now I am going to ping 12.1.1.2 from here, from this machine. Tell me, once I will hit enter, which type of traffic this machine will generate?
So if there's nothing, like you said, if there's nothing in the ARP table, it will be waiting for.
First of all, it will generate, ICMP traffic. It will not send this traffic because this machine is not able to encapsulate the frame now. Because this machine need what? MAC address of 12.2. If you will ping 12.2 from 12.1, 12.1 needs what? Destination IP, destination MAC, source IP, and source MAC. Yes or no? So this machine have source IP, this machine have source MAC address. You already told to this machine that destination IP address is this one, but who told to this machine that what is the destination MAC address? For that, this machine will check their ARP table.
ARP table.
So IP ARP. Are you able to see any entry for 12.2? No, there is only one entry for 12.1. Right? This is the IP address 12.1 and this is the MAC address of 12.1. So this machine will put ICMP traffic on hold and it will generate what?
ARP.
ARP. Okay. So I am talking about that ARP. In the ARP message, tell me what will be the source IP address?
In the ARP would be the
now
source.
Now my ICMP is here on the hold. Yes?
Okay.
This machine have to generate ARP request. What will be the source MAC address?
Will be the MAC address,
of sender.
Routers.
What will be the destination MAC address? broadcast.
would be the FFF.
What will be the source IP? 12.1. What will be the target IP address, destination IP address?
.2.
12.2. Yes, I am looking for the MAC address whose IP address is 12.2. Yes or no?
Yes.
Let me show you. So here is again capturing in front of you. Yes. Now router 1 and let's say ping 12.1.1.2. Oh, are you able to see ARP? After that ICMP traffic. Yes. Now everything is here. Once you will, I have hit enter. First of all, this packet is generated by 12.1. Yes or no? What asking? Who has 12.2? Tail to 12.1. Yes or no? If you will
Yes.
open this ARP request message in detail, what information are there you are able to see. Source MAC is MAC address of router 1. Destination MAC is 000. But in the Ethernet header, source MAC is MAC address of router 1. Destination MAC is broadcast, right?
Yes.
Source IP is 12.1 and target IP address is 12.2. So 12.2 will generate what? Reply. Are you able to see this message? This is ARP reply. How we identify ARP request and reply? With the help of, type code. In the ARP packet, you are able to see opcode here. Opcode 1 means it is an ARP request. Got it? And in the reply packet, are you able to see this reply packet? Here you can see type code is what? 2. Opcode is 2. So 2 is for reply. Always keep in mind ARP request opcode is what? 1 and ARP reply opcode is 2. Interviewer can ask you this question. Okay, and I multiple time I will also ask you this question. How interviewer will ask you question and how interviewer is asking this question from here. What they will ask? They will ask you like this. This is my scenario. This router don't have the MAC address of 12.2. So this machine will generate what? ARP request. How this router will came to know that this is a ARP request? When this machine will receive ARP request, how it will came to know that this is a ARP request or this is ARP reply? So with the help of opcode. Okay.
Okay.
Only opcode, right? If opcode value is 1, that means someone is requesting for the MAC address. If our value is 2, opcode value is 2, that means someone has shared their MAC address. And now if you will check ARP table of router 1, here if you will run command now, show ARP. Are you able to, not ping, show ARP. Are you able to see the MAC address of router 2?
Yes.
Yes. So until this entry will be there in the ARP table, this machine is not going to generate what? ARP. If I will ping now, see, this is my traffic. I am going to ping again. See, it is generating directly ICMP traffic, yes or no? Why it will generate ARP now? Because it have already the MAC address of 12.2, yes or no? And this entry will be there for how much time? Until when this machine have learned? Until 3 minutes, yes or no? This entry is available here. And this entry will be there for 4 hours. For 4 hours. After 4 hours, it will remove this entry. If you will not send any traffic to 12.2 from 12.1, within 4 hours, it will remove this entry. Got it? Okay.
Yeah, man.
So,
Yeah, man. Can you tell me once again if you, because
yes, no problem.
please.
But when I will
Yeah.
ask question, at that time I am expecting, answer from you guys. Don't worry.
Sure.
I am explaining you again. See, I have configured this IP address over here. I have configured this
Okay.
IP address over here, right?
So what we are looking actually is when we are
We
generating
are,
our request. So what we are finding now actually.
I am trying to make you understand packet flow between two routers. How packet will
Okay.
flow.
Yeah.
Okay. So what I'm saying that when you will ping, when you will suppose this is not a router. Suppose this is my router, right? This router is connected with my ISP, and this ISP is connected with Facebook server. Suppose this one is FB server. Okay, here is my computer, right? I want to access FB server. I need IP address of FB server, yes or no? I need
Correct.
MAC
Yeah,
address
that
of
is
my default gateway, yes or no?
Yes.
Right? So you will tell to this PC that what is the IP address of Facebook, or there will be a DNS server who will be
correct.
responsible
DNS.
to provide the IP address of FB server, right? But who will be the responsible to provide the MAC address of default gateway? For that, machine will generate what? ARP. ARP request. ARP stands for Address Resolution Protocol. It is used to resolve MAC address from IP address whenever a machine know the IP address, destination IP address, but they don't know the MAC address. The machine can call to this protocol, right? Suppose I have a servant at my home, right? And I need, suppose, bottle of water from shop. What I can do, I can call him, right? And I can tell him to please bring a bottle of water from the shop. Like that, this protocol is available ARP on all devices. Whenever machine needs MAC address from IP address, devices can simply call to this protocol, yes or no? But when machine will call to our protocol, when machine will not found any entry in the ARP table, yes or no?
Okay.
Mm-hmm.
Okay.
Yes.
That means without any entry, the time you will call this ARP message.
Yes. Suppose Bijay, suppose you are router 1 and I am router 2, right? I want to send you some packet. I need your MAC address as well. I need your IP address as well. Then only I can send you packet, yes or no?
Correct. Correct.
Right?
Yes.
So suppose I know your IP address, but I don't know your MAC address. So I will call to our protocol. Hey ARP,
ARP
please
protocol.
resolve the
Then
MAC address of Bijay, right?
okay. Yeah.
And it is responsibility of ARP how it will resolve, right? So for that, what ARP protocol will do? ARP protocol will generate one ARP request. How we identify ARP request? With the help of opcode. Yes or
One.
no?
Yeah.
With the help of
Yes, ma'am.
opcode.
ARP code.
In the
Code.
opcode value will be 1, that means it is an ARP request. If opcode value is 2, that means it was an ARP reply. There are two types of messages in ARP. ARP request and ARP reply.
ARP reply.
There will be some more information as well, right, in ARP packet. See how many information will be there in ARP packet. Where is ARP? Here it is. This one is ARP request. Let me open it and let me show you the entire information. See, this one is address resolution protocol ARP packet. Yes. There will be information of hardware type. There will be information of protocol type. There will be information of hardware size, protocol size, and opcode. After that, sender MAC address, sender IP address, target MAC address, and target IP address. Right? These 4 information are essential in the ARP request. An interviewer will also ask you question from these 5 right information. Okay. So this is clear
But
to you, opcode.
yeah, that the target IP address. How if we generate that ARP request to
You
them?
you told na, I told to machine
I'll-
to router 1 ping
Okay.
12.2. Yes.
Yeah. Okay.
So machine is looking for the MAC address of 12.2. If I will ping 12.3, it will generate ARP for 12.3. Before generating ARP, it will check their ARP table, that is entry available for 10.3. So see, in the ARP table there is no any entry for 12.3. Yes, so it will generate ARP for 12.3. Target IP address will be 12.3, right?
Right.
Yeah.
Getting my
Okay.
point?
Clear. Yeah.
Yes.
So what is the difference between ARP request and ARP reply? See, let me show you the ARP reply as well. This one is ARP reply. In the ARP reply, also information are same, but this is a unicast traffic. Here are you able to see destination MAC is unicast.
Yeah.
Right? Sender, this time who is generating this traffic? 12.2, and this time target become 12.1. Yes, and it is sending the target MAC address. This one is the MAC address of 12.2. So once router 1 will receive this request reply message, it will learn this MAC address, right? It will make entry in the ARP table, and here opcode is 2. That means it is an ARP reply. Clear? So
Okay.
interviewer can ask you that how to identify ARP request, how to identify ARP reply, what will be the information inside ARP request, what will be the information inside ARP reply, when machine need to generate ARP, why machine need to generate ARP, what is ARP, right? Multiple question interviewer can ask you,
Okay.
right? So again, I
Right.
am telling you, ARP stands for Address Resolution Protocol, which is used to resolve MAC address from IP address. Whenever a machine know the destination IP address, but they don't know the destination MAC address, machine need to generate an ARP request to resolve the MAC address from IP address. That's it, okay?
Okay.
If I will speak 1,000 times, I will speak same line. Okay,
Okay.
brother. After that, ICMP request. Right? My actual packet was ICMP, not ARP. Right? If you will ping from here to here, it will generate a ICMP. Ping is what? Ping is just a utility, right? That is used to check connectivity. But if you
Your voice
are,
is breaking, man. I didn't get your voice clearly.
let me check my internet
Yeah, yeah,
speed
yeah.
once.
Yeah, now it's okay. Before your voice is breaking actually.
1 second, 1 second. Internet speed. Let me check the internet speed. Because this is my new setup here. Internet speed should be much better.
Okay.
Oops.
Yeah,
I think it's
17. Okay.
fine.
But your voice is breaking, but now it's fine. Yeah, now it's fine. Before two minutes back, your voice is breaking.
Now it's okay?
So, yeah, yeah. Now I
Yeah,
am
yeah,
getting it.
that's fine.
Okay, okay.
It was flop is like your voice has
Okay, now it's
breaking.
okay now?
Yeah, yeah, now it's okay.
Yes.
Please carry on.
So, if you will ping from here, what is ping? Ping is an utility which is used to check connectivity. That's it. But which protocol is responsible for ping? ICMP. ICMP is a layer 3 protocol. Yes or no? Which is responsible to check connectivity between source and destination. Fine. So once you will type ping and 12.2, and if you will hit enter, this machine will generate one ICMP. Same request. There are again two types of packet in ICMP. ICMP request and ICMP reply. Which protocol will generate this ICMP request? ICMP protocol. ICMP is a protocol which works at layer 3. ICMP stands for what? Tell me.
I
ICMP?
Internet Control Messaging
to internet
Protocol.
yeah, internet control message.
It is a layer 3 protocol. You know, if you are working in this industry, networking industry, you should, you should have knowledge about ICMP. Very, very important protocol for beginner only, right? Not for
Yeah.
advanced. If you have experience of 1 to 2 years, and if you don't know what is ICMP, that's
Yeah, man.
okay. Sam,
Yeah.
Yes.
ICMP is an, entry level
Internet.
protocol. This is
Okay,
below
man.
CCNA.
Basic foundation of going on.
Okay, no problem. I will
Yeah.
make you understand. So see, ICMP stands for Internet Control
Thank
Messaging
you, man. Thank you.
Protocol, which works at layer 3. That means ICMP will generate their traffic at layer 3 directly.
Yeah, please. Okay.
Right? So if you will ping, it will generate ICMP request. After that, it will hand over to IP protocol. IP protocol will do what? It will add one IP header. In IP header, what will be the information? Source IP. Source IP will be 12.1. Destination IP. Destination IP will be 12.2. Right? After that, there will be one field called type protocol field. Sorry, not type, protocol field. With the help of this field only, this router, when this router will receive this ICMP request, it will came to know that this is an ICMP traffic, right? So protocol number of ICMP is 1. What is protocol number? Oh my god. Sam,
Yes.
what is protocol number?
For the would be one, right?
Protocol number of ICMP is
The
1. Protocol number of EIGRP is different. OSPF is different. TCP is different. UDP is different. I am not asking you what is
yeah,
protocol number of ICMP. I am asking you what is protocol number. That's it.
protocol,
Protocol number.
TCP protocol or normal?
Protocol number. Simply my question is, suppose you are sitting in front of interviewer, you are giving interview for a job in Cisco, and interviewer is asking you to please explain protocol number. What will be your word?
8 man.
I I mean, I don't get your question. Like, you mean the definition of protocol number, or
No, I am not asking about the source destination. I am simply asking you what is protocol number? What is protocol number?
right? Right. I
Like
mean,
what is
yeah.
router?
You mean the definition of
Yes,
what
definition of protocol number.
it's like a
Datagram
value.
header,
It's
no?
like
That
it's
is
like a value
protocol is
in
single byte
in
and
in a header.
Value in header? No.
datagram header, no?
No. Whatever protocol we have in networking, each protocol have a protocol number for the identification.
Yeah, protocol 6 na man.
It is an
Protocol 6 no?
protocol number is an unique identification of a protocol. Can you tell me 10 protocol? Hello?
Yeah, I
Yeah,
don't
man.
quite understand your question. So, yeah.
You didn't understand my question. My
No, no.
question is, can
Wait.
you tell me
No, no,
10
no.
protocols in
So
networking?
so
Like
I
we
mean
had
you
discussed two na, ARP and ICMP. Tell me 8 more protocol.
um
Okay, one I am again telling you
Yeah,
HTTP.
UDP. I am
Okay,
telling you, man.
yes,
UDP,
HTTP.
POP, SMTP,
Okay,
FTP, HTTP,
SNMP,
HTTPS, SMTP.
HTTPS, SM, SNMP हो
Yeah,
गया.
Telnet,
Telnet.
Telnet,
Okay,
Gopher,
Telnet.
Gopher,
Else 4.
POP, POP,
POP
POP,
3. Okay, leave POP 3. Now we
POP
are not
3.
using POP
Yeah,
3.
FTP,
okay.
FTP,
FTP, TCP,
TCP,
IP, I guess. IP.
IP.
IP. Yeah,
IP, IP is an, routed protocol, right? Leave IP
There's
for now.
UDP,
RTP.
RTP.
the
Yeah,
RTP
no
stand for what?
the
Have
real
you heard
time
about this protocol?
SMTP.
HT. Yeah. I know.
So
Currently, we
this
are
is
using, man.
this is important na for networking student. Why
There's
you
DHCP
guys are not
protocol,
mentioning
yeah.
this
Dynamic host control protocol and
DNS,
RTP, DNS,
DNS. Yeah.
BGP,
L2TP,
OSPF?
SMP,
These protocols
TFTP,
nowadays all organizations are using, but you guys are
yeah,
not
BGP.
seeing this one. You guys are going, I think, SNMP aside, POP3, IP.
You know, man, we are telling one by one.
Okay, tell me. Next,
BGP,
Then
RIP.
BGP.
L2TP,
Okay. We have already discussed 10. Now tell me what is the protocol number of HTTP?
HTTP is 80, man.
80,
It
and
is
then
port number.
Mm.
There is okay. Tell me what is port number? Port number, because it is very important to make you understand port number and protocol number. There is huge difference between protocol number and port number, and many people are confused between these two terms.
yeah, that's definitely, yeah. So the port number.
Port number.
The protocol number is 80. Yeah. Okay, I get it. The port number. Okay,
This
I
one is
see what
not protocol number. This is a port number. Yes or no?
I see what your question is. Yes, the port number is 80. Yes, for HTTP. Yes.
Now my question is not this. Now my question is what is port number and what is protocol number? Can you differentiate?
Yeah, actually, port is
Yeah.
Port number will tell you the application layer services.
yeah, application layers and Cisco.
Yes or no? And protocol number tell you the services just after network layer. Suppose a traffic which is generated by OSPF, that traffic will be generated at layer 3 because OSPF works at layer 3. So OSPF don't have any protocol number, sorry, port number, yes or no? Because port number is a part of application layer, layer 7. But OSPF is generating traffic at layer 3.
Can you repeat again? The protocol
Yes,
number is the service after the networks layer.
after network, just after network layer, right?
Okay.
After network layer, which layer are there? Transport layer, yes or no?
Chairman, tell me
Yeah.
once again that port and protocol, that difference.
See here, after this is transport layer. Again, I
Yeah,
have to teach you OSI model.
OS.
Transport layer and network layer,
Yeah.
right? Here is suppose application layer.
Mm-hmm.
Application layer, right? On application layer, there are multiple services like HTTP, like DNS,
Mm, mm,
like DHCP,
yes.
yes or no? So
Yeah.
these
Yes.
services can be identified with the help of port number. Yes. At transport layer, we have two protocols, TCP and UDP. And at network layer, there are lots of protocol like OSPF, EIGRP,
Yeah, RIP. RIP not using.
EIGRP. No, RIP is and also application layer protocol.
Okay.
So all the protocols which work at application layer, they will have port number. But the protocol which is running at layer 3 or layer 4, they don't have port number, they have directly protocol number. Yes. So at network layer, these protocols are running OSPF, EIGRP, ICMP, right, for the ping. So these protocol have protocol number. Suppose at network layer, how anyone can identify HTTP traffic? They can identify because HTTP is using which protocol at transport layer? TCP. So TCP have one protocol number. Can you tell me what is the protocol number of TCP?
21, man.
Can you check it on Google? Please check. What is the protocol number of TCP and UDP? Just I am coming.
Yeah, TCP 6, man. That
Yes, 6.
TCP.
TCP
Yeah,
protocol number is 6.
6.
Right. So at network layer in IP header, there will be information in protocol field. If value will be 6, then network layer will come to know that now I have to send actual traffic to TCP. Yes or no? If protocol number will be 89, it will send to EIGRP, not TCP or UDP. Yes.
Okay.
If
Yeah,
tell me
yeah.
what is the port number of UDP?
Should be
Protocol number of UDP? It's
it's either
19.
Protocol 19.
Right? So in IP header at layer 2 protocol field value will be 19. That then only network layer will come to know na I have to hand over traffic to UDP at transport layer, because at layer we have protocol and protocol is responsible to encapsulate and decapsulate traffic. Yes or no? Do you think that transport layer can encapsulate packet or network layer? No, there are protocol for that. Yes. So
okay.
all the protocol which is running between transport layer and network layer, they have protocol number. Yes. And all the protocols which works after transport layer, they have port number. With the help of port number, you can identify the services at application layer, right? With the help of port number, you can identify the services after network layer, right? So see, suppose this is an ICMP traffic. Where is my capturing? Here. This is ICMP traffic. Who is sending 12.1 to 12.2? So when 12.2 will receive it, it will do what? It will check IP header. In the IP header, it will check destination IP. So destination IP is 12.2. Yes, this is for me. After that, it will check what? ICMP packet. And in ICMP packet, What it will check? It will check protocol field. Are you able to see protocol field?
Yes. Yes.
Here you are
Yeah.
able to see protocol field, and protocol number is what? 1 for ICMP. So with the help
Hmm.
of this protocol field, network layer will come to know that this actual ICMP, this is a traffic of ICMP. Right? By with the help of this information, network layer will hand over ICMP traffic to ICMP protocol. Yes or no? And how ICMP will identify that it is a request or reply? With the help of type code. So if type code is 0, that means it is an reply, and if type code is 8, that means it is a request. Yes.
Request one, replay zero. Huh?
Request 0, sorry, request 8 and reply 0. In the reply packet, here is reply, ICMP reply. Here you can see, okay, type code is 0 for reply.
Okay. Zero is
Okay,
replay. Okay.
ARP opcode 1 is for ARP request, ARP opcode 2 for reply, type 8 is for ICMP request, type 0 is for ICMP reply. Okay, and ICMP have which protocol number? 1. So as a network engineer, you have to always keep in mind 20 protocols, 20 important protocols, and port number of those protocols.
Okay.
So make sure after this session, you will search on Google, right?
Yeah.
What is the,
Already I took protocols, all the protocols, man.
TCP, UDP,
So many
whatever
protocols
protocols
are
are
there.
there at network layer. You will mention,
Yeah.
you will note down all protocols in your notebook, and you will mention the protocol number. Okay. I have also share, let me show you. I have also share one notes, my hand written notes. There I have already mentioned these things, but definitely you guys have not opened that book. These are below CCNA. Where is? I think this one, CCNA routing and switching. Nope. Let me search over here. Where is my note? CCNA security, CCNA, not this one, not this one, not this one. I am looking for which one? No. Basic networking. Introduction to network paper. Basic RIP configuration. Where is my folder? Just give me 1 minute. I am checking. Okay. Nope. Cisco networking for beginner. Here, are you able to see protocol number and port
Okay.
number?
10,
I am
10.
sending you in group as well. These are important, but here are very less. At least you have to remember 50 protocol and protocol number.
Okay.
Okay, let me share it in with you to Sam also and to Vijay also. Yes. So when you will ping, what it will do? It will check their ARP table. If there is entry for the 12.2 MAC address, it will directly encapsulate ICMP traffic. What is the meaning of encapsulation? Now let me ask some question to you guys. Very basic questions of entry level. I am pausing. If 1000 user will generate a request, HTTP request, destination port will be same, right? And after, here you can see this is my actual data and this is extra information. Yes or no? After adding extra information and transport layer, we You will not call it at data. You will call it at segment. Now this is not your data, this is segment. What is the meaning of segment? Segment means my actual data and plus transport layer header. Yes?
Yes.
Because receiver machine have to remove this information. These are extra information. Right? This is not the user information. What we call it segment. Segment means actual data plus transport layer header. It can be TCP, it can be UDP. After that segment, this is segment. This segment transport layer will hand over this segment to network layer. Network layer will receive a segment. Network layer will do what? Network layer will add one IP header. In IP header, it will have source IP. Source IP is suppose 12.1, destination IP 12.2. After that protocol. So who hand over this data to network layer? TCP or UDP? Don't say transport layer. There are protocol. Who provides this segment to network layer? TCP. So there will be protocol number of TCP. What is the protocol number of TCP? 6. Now here you can see this is segment and this is extra information at
Package.
network layer. What we call it? Packet.
Package.
Packet means what? Packet means segment plus IP header. Right? And after that network layer will hand over this packet to data link layer. Data link layer will receive a packet. Right? And data link layer will add one Ethernet header with this packet. It will add source MAC. MAC is A, destination MAC is suppose B. After that there will be one field called type field. In type field there will be information that who have hand over this packet to me. So IP protocol, not network layer. IP protocol from network layer hand over this. So there will be type code of IPv4 0x0800. Yes?
Yes.
And what we call it? Frame.
Frame.
Frame means packet plus
Packet plus MAC address.
data
MAC
link
address.
header.
Data link header.
And then data link layer will hand over it to physical layer. Physical layer will convert it into bits, into signal, and then it will transmit on the link. Yes or no?
Yes.
So what layer are doing? Layers are adding extra information with actual data, and this is nothing but encapsulation. Encapsulation means adding extra information with actual data to forward actual data to the right destination. These information are only for to reach this actual data to right destination. Yes or no?
Yes.
Otherwise, user don't need to do anything with these information. Yes or no?
Yes.
So what is encapsulation? Encapsulation means adding extra information
Adding
with
extra
actual data. This one is your encapsulation. But when server will receive, at which layer it will receive the data? At physical layer. Physical layer will convert it signal into bits, then bits into frame, and it will hand over to data link layer. Data link layer will receive what? Frame.
Yeah.
So data link layer will open this frame in detail. In the frame, if data link layer will open this frame in detail, there will be one packet, yes or no, and header. So it will check in header, destination is what? Destination is B or not. If destination is B or destination is broadcast, then only I will accept it. Otherwise, suppose destination is C, at data link layer, the server will discard it, yes or no?
Yes.
It will accept only in two cases, if destination is B or destination is broadcast, yes or no?
Yeah.
Otherwise this machine will not receive it. Okay, so destination is B. Yes. Server will say, yes, someone have sent something for me only. Now this at data link layer, receiver machine have to identify that what I need to do with this packet. For that it will check type field. In type field there is information of IPv4. So what data link layer will do? Data link layer will simply remove this header and it will pick this packet and it will hand over this packet to network layer.
In data
Right?
link,
Now network
that
layer have one packet. It will open this packet in detail and it will check destination IP. If destination IP is broadcast and 12.2, then only it will accept. So destination is 12.2. It will check what? Protocol field. Protocol field value is what? 6. What network layer will do? Network layer will remove this header and it will hand over this segment to TCP, not to UDP, because protocol number is 6. What TCP will do at transport layer? It will receive a segment. Again, it will open segment in detail and it will check destination is what? 80. That means this is a HTTP traffic. It will hand over to HTTP at application layer. Yes or no? If there will be value of 23, it will hand over to tailnet. If here value will be what? Suppose 53, it will hand over to DNS3. Yes or no? So this is what? Receiver machine is removing extra information. This is decapsulation. Encapsulation means adding extra information with
Additional
actual data,
informations, yeah,
and
with actual data,
decapsulation
and
means removing extra
removing that
information.
extra information.
Encapsulation and decapsulation, very important, technical word in networking, in computer networking, below CCNA. Encapsulation and decapsulation. Whenever machine will send data, machine have to encapsulate, and whenever machine receive, it have to decapsulate. And whenever machine encapsulate and decapsulate, it will use your CPU utilization. Yes or no?
Yeah.
I was giving interview in Sophos. They asked me one question, that technology is shifting from broadcast to multicast. Consider RIP version 1. RIP version 1, say update was sended at broadcast message. In IPv4 also there is one term called broadcast, but in IPv6 there is no any term like broadcast. So technology is really shifting from broadcast to multicast. So what is the benefit? They ask me in Sophos, what is the why technology is shifting from broadcast to multicast? Suppose here I have a router, here I also have a router too. If here I have configure EIGRP. Here I have not configured EIGRP. So this machine will send EIGRP message to this router, but here I am not running EIGRP. So this machine will came to know that this is a data of EIGRP at which layer? At which layer? At network layer. So at network layer it will remove. That means it have to perform decapsulation and transport layer. At data link layer. Yes or no? Means it will
Yes.
use their CPU utilization. But if it will send on the multicast address, it will check that I am member of that multicast group or not. If I am not member of that multicast group, why I will accept this packet? Yes or no? Simply it can drop. So this is the benefit. If any machine will receive a message on broadcast address, it have to read. But if machine will receive at broadcast at multicast, it will check that I am member of that multicast group or not. Okay. So this is the benefit. So
This,
encapsulation and decapsulation, clear?
yeah, this is TCP IP model, na, Prabhu?
Yeah.
So let me ask you one thing.
Yeah.
So so you went through everything in detail, right? So let's say if we are in an interview, like do they really ask you to break it down, like every single one, or like or they just say, hey, can you tell me the encapsulation and decapsulation process, where we tell them, okay, when you get to a transport layer, you put in a TCP header, and then once you get to the network layer, you put in the IP header. Is that good enough, or do they want to tell, or they really want you to, like, okay,
You have to read book. This
uh-huh,
is not enough. This is only 10%. You have to read 90% from
yep,
book.
yep, okay.
Correct. Yeah. Just clear the concept.
If
Now
you will
we
read
need to
book,
read
na,
more books. Yeah.
yes, if you will read encapsulation after this session, just do one thing. Just search on Google what is encapsulation and decapsulation, right? Whatever terms you are getting, stop the reading and find that term first. Here I am typing encapsulation. What is encapsulation and decapsulation?
Yeah, yeah, I already typed encapsulation, add information
What
from
is
No, no,
saying
process type. I will
encapsulation
tell you.
adds
no, no, no,
information to
no.
a
I think you get I think you get my questions wrong. What I'm trying to, I know what encapsulation does, and I know what decapsulation does. Like a certain
Okay.
step, like let's say a package. It if you're going to from a physical to a data link, you put in the header and stuff like that. But what I'm asking is, let's say in an interview, when you
Mm-hmm.
say you go from one layer to another layer, right?
Okay.
You add a TCP header and then you add the IP header. Is that good
Mm-hmm.
enough to an interviewer, or
Yes.
they want me to say, okay, if you say you adding a TCP header,
No,
tell me what.
interviewer will ask you very basic question. Like interviewer will ask you that if a machine is generating HTTP traffic at transport layer, how you will identify? So what will be your answer? At transport layer, there is one field, right, in TCP, destination port. So in destination port, value will be 80, right?
Okay, that's all I want to
Like this
know.
you have to tell to interviewer. If
Okay.
interviewer will ask you that how network layer will identify that this is a UDP traffic or TCP traffic, you have to tell that there is one field called protocol field in IP header. With that field, anyone can identify that this is a traffic of TCP or UDP. They can ask you that how you will identify which protocols I have to use at the network layer, at data link layer, right? Suppose you are a receiver machine and you have received a packet at data link layer. How you will came to know that I have to hand over this actual data to which protocol at network layer? Because
Hello.
there are million of protocols running at network layer, right?
Okay,
So with the
got it.
help of type
Ah,
field,
okay, 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 okay.
Okay,
okay,
got it.
always keep in mind field, source port and
No need, no
destination
need.
port at transport layer, protocol field are there at network layer, and type field are there at data link layer. These three terms are very important. Okay, and this is packet flow. This is how you can explain the packet flow between two computer, between two routers, between two switches, and between ISP and router switches, anything.
Got it.
Okay, in packet flow you have to explain encapsulation and decapsulation only.
Okay.
See, in my capturing also, this is ICMP traffic. So is there any information about layer 4, about transport layer? No, because ICMP work at network layer. So directly traffic will be generated at network layer. So that's why you are able to see ICMP, after that IP protocol at layer 3, after that Ethernet header, and then physical layer. There is no transport layer. But if you will send generate HTTP traffic or DNS traffic, suppose here I am going to say, what I am going to say to router number 1, IP address DHCP, it will generate what? Discover message, yes or no? Interface F0/0 say no IP address, and IP address DHCP. I have stopped the capturing. No, here are you able to see the discover message?
Yes.
See, if you will open it, are you able to see transport layer here? UDP, user,
UDP.
datagram, protocol, source port, destination port. Yes.
Mm-hmm. Mm-hmm.
After that, in IP header, are you able to see protocol field? Here are you able to see value 17?
Mm-hmm.
17 is the protocol number of UDP. By mistaken, I think I said 19.
Mm-hmm.
Okay. Are you able to see protocol? And in the Ethernet header, you are able to see, type field. Where is type field? Here. Are you able to see type field?
Mm-hmm.
And this is the type code of IPv4 only.
Mm-hmm.
That one I have doubt, man. That type we are using now. So what is the type? That I
Suppose they see this is the type code of IPv4. Okay.
okay.
Now
IPv6 means
let
it's
me show
different.
you one more thing over here. This is your ARP packet. This is your ARP packet. Yes or no? So here in Ethernet header, you are able to see the type.
Hmm.
Yes.
Yes. So Ethernet header means data link layer. If data link layer will see this information right in the type field, it will hand over actual data to our protocol. Yes or no?
Yes.
If in the type field value will be 0x0800, it will hand over to IP protocol at layer 3. Yes? Getting my point?
Yeah,
Yes.
okay.
Yes.
What I'm saying, the type field is there in Ethernet header. With the help of this type field, machine will identify that I have to hand over actual data to which protocol. Who is responsible upper than me? Yes or no?
Okay.
At network layer, who is responsible upper than me? For that, there is one separate field called protocol field. At transport layer, who is upper than me? For that, we have destination port. Yes or no?
Yeah, man. Correct.
Okay.
Okay,
Type
so
field in
please,
header.
you will read these things in book as well, and tomorrow again, or maybe tomorrow, or when I will discuss routing or switching these things, I will ask you this question.
Yeah, okay, man. Okay.
Okay, and if you guys will not answer now, it will really hurt me a lot, because
Okay.
no one can provide you training like this,
Type field in
That's
header.
why we come to you, know, man.
right?
Really,
But
yeah. See,
but if you guys
which
will
which
not
we
practice,
don't know. That's why we will come to you.
no problem. I am telling you now, I will make you understand everything.
Okay,
It's
man.
my
Okay, okay.
responsibility.
Yeah, 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 yeah. Okay. Sure,
Okay,
man.
Sam.
Okay.
Yes.
So I will send you the recording, and